Hi, I put together some slides for a pedestal at the InfoSphere demo room at the Insight conference, and I thought I'd go through them with you guys here for anyone who isn't able to make it to the conference. The title of the pedestal is Analytics that Reflect the Business Now with the Best Data Integration Choice. That's a bunch of words. Hopefully it makes some sense to you now, and it'll make more sense as I go through the slides. The technology I'll be talking about is some data integration technology, data stage, and data replication. Data stage is IBM's ETL tool, so fabulous tool for doing high volume complex data transformations. Data replication is our change data capture technology. The analytics data stores, conventional relational data warehouses, Hadoop, and the discussion here won't focus on any given distribution. InfoSphere streams, that's IBM streaming analytics technology, and then systems of engagement data stores like Cloud or MongoDB. And I'll be talking about 4 trends that we're seeing amongst our clients, and I'll go through each of them individually, and so I'll talk about each of them as I get to them. So, trend number 1, making your existing data warehouse real-time. An important point is that real-time depends on the question being asked. So I've got some examples here. If you're doing historical analysis, it may not be important whether or not the data is 1 day or 2 days or even a week old, because the data you care about might be from many weeks in the past. Again, for a particular question about mailing, depending on how frequently your organization does mailing campaigns. If you're trying to figure out what to put on a truck leaving a warehouse for a retail location, it might be useful to have data that includes sales up until 10 or 15 minutes ago, so that if some customer comes in and buys out some particular flavor and brand of yogurt, then the truck that leaves that next hour can contain that more of that to restock your store. If you're trying to target offerings for your cell phone clients, I know myself personally, I really am almost scared of overage charges. So if my cell phone company sent me some notice saying, hey, we just noticed you sent the last of your free text, any more text is going to cost you money unless you update your plan, I think, wow, that's a cell phone company that understands my particular paranoia, and I think that would be really valuable. I'm just going to, so I just built that slide. So as you look to move to have more current data in your warehouse, there's 3 different sorts of load patterns that we talk about. Traditional load, you get all the data from your system, transform it, load it into your analytics. Incremental, where at regular intervals you get all the new changes and you update your analytics system, so it stays static for a while and then it gets made up to date, and static up to date incrementally. Continuous, as the name suggests, as database changes occur, they are continuously captured from the source and updated to the analytics system. And as you see in the chart on the bottom, the traditional load tends to give you currency that's days or maybe hours. Incremental load tends to be hours down to minutes, and then continuous load is where you get down to minutes to low numbers of seconds. There's 3 technology patterns that are in some ways tied to the load patterns as well, although not entirely. So you can use data stage on its own, you can use data replication with data stage, or you can just use data replication on its own. And again, as you look at the chart at the bottom, as you move to bring data replication, you tend to be talking about lower latency, so more current data, and if you for your lowest latency needs, you'll probably want to be looking at data replication on its own. Things to consider as to which of these patterns to use: of course, the functional requirements. Will you be able to get the currency of data you need, and can that pattern do the data transformations that are required to get data into the right structure for your analytics system? And then non-functional requirements. Often your source system will be overloaded. To minimize the impact on your source system, data replication is always going to be a good choice. Data replication is designed to be the least intrusive way to find out what changes are occurring in your source system. But you also want to minimize your overall cost of ownership. So a solution that involves a number of technologies is generally going to be more expensive than one that involves just a single technology. On the other hand, you also want to leverage existing expertise. This trend, as we sort of titled here, the trend was around moving existing data warehouses to have more current data. So we find that our customers often have significant intellectual property in the design of their existing ETL jobs, their existing data stage jobs, and you certainly want to be looking to continue to leverage that intellectual property while you move to more current data rather than discarding that and essentially starting from scratch. So specifics to the technologies, data replication supports basic transformations. The simplest way to think about it is that if you can think of your target table as a view on one or more of the source tables, data replication can do that transformation. Another way to think about it is that if the structure of the source and the analytics are the same, they're both OLTP or they're both OLAP, then data replication can do that transformation on its own. If your source is OLTP and your target is OLAP, that's beyond what data replication can do on its own. You're going to need to bring in the transformational power of data stage. Using data stage on its own with low latency, so getting really current data, the key thing is that data stage needs to be able to identify what changed in the source system. So you need to know something about the source data and your source application. Many source applications do keep timestamps indicating when some record was changed, which can make it quite simple to query the source database to find out, here's all the data that changed since some previous point in time. Another consideration is around deletes. If your application actually just deletes data from the source database, change data capture, data replication can capture that delete operation, but any post-querying just can't because the data is not there. But again, very few applications actually delete data from your system of record, and instead, often those things are essentially logically deleted. If a customer removes themselves from your system, you're probably not deleting their customer record, but instead just marking it as inactive. So as you think of all those things, back to the examples, for the historical analytics system, data stage on its own can probably provide the currency you need and is going to be a nice simple solution. Just-in-time restocking, in general, you'll probably find that there is a significant structural difference between your point-of-sale system and your actual inventory warehouse system, so that data stage and data replication together would likely be a good choice. The targeted offerings there, because you're really looking at low seconds of currency for getting your answer, data replication on its own is going to likely be the right choice. Trend number 2, creating a Hadoop data warehouse. There's a couple of reasons our clients are thinking about this. One is as a discovery zone, a place for their data scientists to look for new business value in their existing information assets. In that world, the active data, the data that changes as your business operates, that data they want updated continuously into their discovery zone. And as well, just as a general principle, they don't want transformations to occur. They want all the data there as it existed in the source system, so that you're not making any sort of prejudgments about what will be interesting data for them and what sort of analytics they'll want to do. The other use case is as a cost-effective archive. So rather than having your archive data offline, you can have it online in Hadoop. And it can often be useful for doing different sorts of analytics than you might do on your more recent, your last 1 or 2 years worth of data. The technology to use here, there's really 2 different places to put the data into Hadoop. Landing it in HDFS, which allows you to work directly with MapReduce or via Hive. The active data, this data that changes as your business operates, it's useful to have an audit trail of the change that occurred. So not just what does the data currently look like, but what has it changed through the course of the day, through the week, through the months. If you only care about the current state of the business, you can use the power of MapReduce, you can use Hive to really create a view on that data that hides the archive, the audit trail. But you can look at the audit trail when it's when it can provide interesting feedback for your analytics. So for this active data, using data replication on its own makes a lot of sense. It naturally creates this audit trail of source changes, and it can apply data directly to HDFS. For your reference data, the data that really essentially doesn't change from day to day, using data stage to just grab a copy of that data makes a lot of sense. Landing data in HBase, this is often more if you're doing more conventional SQL type querying. You want to have lookups. You don't want to do lookups out to your system of record. You want to move the data closer to your analytics. Data replication is not able to apply directly to HBase. So there, for your active data, you'd want to use data replication and data stage together. For your reference data, you could use data stage on its own. Trend number 3, bringing business data to your web and mobile application. So here's a picture of the model that we think makes sense in this world. So you'll have your mobile application working with your system of engagement database. I've labeled it Cloud in here. It could equally well be MongoDB or something else. You'll have your business application that has its underlying database. We think it makes sense to use data integration technology to make a read-only copy of that system of record data into your system of engagement database, so your mobile application has one place to go to learn both about the system of engagement data and the underlying business data behind that in your system of record. But it wouldn't make sense for your mobile application to attempt to directly change that system of record data. Instead, if the mobile user wants to make an update, say wants to update their phone number or something in their client information, then that mobile application should use the front door of your business application. Often that will be a REST API in the mobile world. So mobile gets a read-only copy of your data through its system of engagement database, but then makes any changes by going through the front door of your application through the REST API. The technology to use here, similar to the real-time warehousing case, in general, your system of engagement data will be a JSON NoSQL database, Cloud into MongoDB, one of those. Your system of record will likely be relational, or it could be IMS. We support data replication for IMS as well, but it almost certainly won't be a JSON NoSQL database. So you need a significant transformation. Data replication can't apply directly to JSON, so for this use case, you'll need to use data replication with data stage together to get the data into your system of engagement database. And finally, trend number 4, streaming analytics on business data. So streaming analytics was first done for sensor data, social media data, all the initial news stories. We're talking about people analyzing Twitter feeds to determine what commercials to show during the Super Bowl, things like that. And businesses were very successful with that. They got a lot of business value, and so as they essentially are expanding that technology, they realized they also wanted to understand and do these sort of analytics on the changes occurring in their business data. And so data replication has a user extension point that you can leverage to deliver the change stream into InfoSphere streams. And our experience here as well is that the InfoSphere streams data scientists don't want you to do transformations on the way in. So they want the raw data changes, and they will do their own processing in the world of streams. So data replication working directly with InfoSphere streams makes a lot of sense in this use case. And in fact, going back to one of the examples I talked about in the real-time data warehousing case, in fact, this creating timely targeted offerings for a cell phone, that's probably a use case where the simplest solution would be in fact to notice these triggering events using a streaming analytics tool, noticing, oh, he's reached his threshold of text or whatever you're using as your triggering events. So those are the 4 trends. This is really as just background material, as I think you'll understand. There's a lot of it depends here. Hopefully it'll help you think about what might be the right choice for you, if you're making that choice on your own, or if you want to have a conversation with IBM about the right technology to bring to solve your business problems. Thanks for listening.